Hi, good morning, one and all. Today we are going to discuss about series combination of cells. Series combination of cells. So, first of all, want to know what is meant by cell. Cell is a two-terminal device. It contains two electrodes. One is positive, another one is negative. It is also known as high voltage terminal, low voltage terminal. Already we know that basic thing. Current can passes from the positive electrode and current direction towards the negative cell, negative electrode. Right. So here it has EMF. EMF means potential difference between two electrodes. Potential difference between these two electrodes is called as EMF when that cell is open circuit. Next, it contains internal resistance also. Internal resistance. Internal resistance means the battery which contains certain internal resistance which is always try to oppose the flow of current. Right. So now here this terminal and this terminal, these 2 points between voltage difference can exist, that potential difference, terminal voltage difference or terminal potential difference. Terminal potential difference. Terminal potential difference V is equal to E minus IR. I means current, R means internal resistance, V means terminal potential difference, E means EMF. EMF means what? The potential difference between two electrodes when cell is in open circuit. Right. So now here combination of cells. Here we consider two cells. So consider two cells of EMFs E1 and E2. Internal resistance, internal resistances R1 and R2. Right. These two are connected in series. Cells EMF E1, E2, internal resistance R1, R2 are connected in series. Series. What is the meaning of series combination? So here, positive terminal of the cell, negative terminal of the cell. Second cell positive terminal is connected to first cell negative terminal. Next, negative terminal of second cell is connected to next cell. So like this combination is called as series combination. So now it is positive, negative, positive, negative. So like this, so on number of collisions, number of cells we have to connect it like this way. It is called as series combination, right? So its EMF is considered as E1, already I wrote. So here its CMF is E2, like that only consider. R1, R2 are the internal resistance. R1 it is R2. Right. So this totally effective cell. Effective cell means total combinations. These two combinations gives the effective EMF. E effective suffix EEFF. E means EMF. E effective. Effective means total or net, like that, or resultant. Same like that. R effective. Why R effective EMF means? So here series combination of cells we want to calculate effective EMF value and effective internal resistance value want to calculate. Right. Now So first of all we should consider point A, point B, point C. It is point A, finally it is point C. AC final. So between B only consider. Here potential difference we should consider V suffix A. Here potential difference is VB. Here potential difference is VC only we should consider. So now net potential difference across two ends or two electrodes of combination of cells. Effective EMF we want to calculate. At the same time internal resistance effective value we want to calculate. Right. So now here potential difference between first cell, two electrodes, positive negative electrodes of two cells potential difference is a terminal potential difference. Terminal potential difference, two electrodes of cell E1. So between two electrodes potential difference is A and B. So that's why VAB is equal to VA minus VB. So VAB is equal to VA minus VB. Okay, right. So here terminal potential difference formula is what? E minus IR. So V means here VAB. So E means EMF. Here what cell? E1 EMF. So that means first cell EMF E1. So that's why E1. Next formula is what? Minus. Current is what? Current is passes. I current only passes. Why? Because in series combination, current is constant. So that's why I only. What resistance is there here? Here internal resistance is there same. First cell internal resistance is R1 only we should already consider. So that is IR1. Right. Next second cell same like that. Similarly terminal potential difference between positive and two electrodes means what? Positive and negative electrodes. Between two electrodes or positive and negative electrodes of cell E2. Same formula, no? Potential difference. Terminal potential difference only we want. VAC. So now, BC here. VBC. Second cell between what potentials are there? B and C between. That's why BC is equal to VB minus VC. So that equal to what? So VB minus VC. VB minus VC, EMF E2, internal resistance R2. So terminal potential difference formula can apply. So what? VBC means this one only VBC equal. E means EMF. What EMF is there? E2 EMF minus current is I only here and our internal resistance is R2. So right. Now the total potential difference or potential difference between, therefore potential difference between A and C points. So that is effective EMF and effective internal resistance will come. So now VAC is equal to generally what? VA and C between VAB minus plus V to B to C. VAC means AB plus BC. Understood? AC we want A to B plus B to C. That is total value will come. So that's why VAB plus VBC. So VAB means what? VA minus VB plus VB minus VC. VA minus VB value what? VA minus VB value E1 minus IR. plus VB minus VC value what? E2 minus IR2. E2 minus IR. Right, it is VAC. So now add these two equations. E1 minus IR1 plus E2 minus IR2. Okay, right. Now E1, E2 take one side. E1 plus E2 minus take common. I also similar. Remaining R1 plus R2. Understood? Here minus I take common. Here R1 means here minus I into R1 minus I R1 plus is minus of plus minus I into R2 I into R2. Okay, right. So it is compare with effective EMF or effective internal resistance value. VSC is equal to, so E effective minus I into R effective. Are you clear, ma? So compare with this equation. Terminal potential between 2 points VAC is equal to effective EMF minus I into R effective. Compare these two. This E effective replaced by E1 plus E2. R effective is at the place of R effective. R1 plus R2 is there. So that is the final value. What E effective is equal to, compare the above equations. E effective is equal to E1 plus E2. R effective is equal to R1 plus R2. So these are the final equations for EMF, effective EMF and effective internal resistance values. So conclusion is the effective EMF of two cells in series combination is equal to sum of the individual EMFs. Next, finally, internal resistance, effective internal resistance of two cells is equal to, in series combination, equal to the sum of individual internal resistances. So this is the series combination of cells. It is also one of the important question for 5 marks. Next, parallel combination is there. Next class I will explain. Thank you.